The way science works is you take published data, and that's what you talk about, and you don't look at things functionally, you look at things siloed. So because there's published data around a gene, clinicians act on that gene. But that's not the way methylation works. Methylation is a baton pass from job to job to job to job, right? So there's this methylation baton pass that happens. So if you don't understand that MTHR is the central character, but there's things upstream and downstream, we don't take proper action.
Kashif Khan, my friend, I'm so happy to welcome you back to the show. Welcome back to the Better Show.
Really good to be here. Pleasure.
It's always such a great time when we're able to carve out some time together and talk about genes. The last time that you were on the show, we were talking about androgen metabolism, estrogen metabolism. We had a really awesome conversation on the nuances around methylation, detoxification, and autism. And now you've put all of your wisdom into a book. The DNA Way is the name of the book. Came out in May. And I'm really excited to do a deeper dive to continue the conversation around genetics, because I think that sometimes you'll hear people say genetics have nothing to do with it. It's just the way you live, right? It's just your epigenetics. And then you'll hear some people say it's all your genetics. So you got the BRCA2 gene and that's it. Just take off your breasts and like that, that's the end of the day. So maybe we'll start off our conversation around, where, and I'll ask you maybe to comment on this, but where do epigenetics and genotypes intersect? So how do we marry our genes and our genetic blueprint with the way that those genes live, called, often referred to as epigenetics? Where's the intersection there and the importance of that?
Yeah, so this is the argument still exists because both arguments are right. Talk to a functional medicine doctor who says, well, I changed their environment and lifestyle and I dealt with the disease. And then talk to another functional medicine doctor who says that it's only because I knew what genes to focus on that I was able to help them. So really, genetics is not about the solution. It's more about what do I prioritize. If I have a migraine, it's one thing to mask the migraine. It's one thing to know exactly what biological system is failing and what epigenetic habit in combination with that failure equal the migraine. And if you think about it that way, both are equally important. I need to look at my human genome and seeing what job does my body not do, or at least not well. And is it a hormone job? Is it a detoxification job, an inflammation job? And if I know that that thing's not happening properly, how does that potentially equal the problem I'm feeling if I now start to consider my habits, my environment, my nutrition, my lifestyle? For example, if I, by the way, did have migraines, it's in the book, right? So when I was suffering from migraines, couldn't get rid of them, kept coming back. What did I learn? I'm missing a key detoxification gene of the gut. I don't even have it. It's not about what version, what variant, missing the gene. And I worked downtown Toronto, ate out regularly with peers, colleagues, whatever, and my food wasn't that clean. So this gut-brain connection, it wasn't a cause. The gene didn't equal the problem. The gene meant that I was the only guy at the table that food triggered the migraines. So both had to happen. But it also gave me the answer on what to unpack and unravel to not have that problem anymore. And I don't have that problem anymore. So unless you're considering both, and this is where these two parties don't talk, the geneticists are over here saying, here's how your body works. And clinicians are over here saying, we don't need your help. Your stuff doesn't work. Right? It's a combination of both. And it just brings things to precision. No more trial and error. No more one size fits all. You get it right the first time.
Yeah, and I have to say that your book does a very holistic job of marrying both of those worlds. So, you were talking about migraines. As you were talking, I was thinking about when I was reading your book, when you were talking about focus. And in the book, you're like, I'm embarrassed to say this, but I've lost my focus writing this paragraph. So you were talking about how, your genetic predisposition, we'll talk about dopamine, we'll talk about COMT, we'll talk about all of these things in just a moment, sort of leaves you a bit more susceptible to lack of focus, procrastination. Yep. And so at the end of each chapter, when we're talking about, let's say, mood and behavior, you're talking about understanding the genes, but, and then the either whether you're heterozygous, homozygous, you have the alleles that are going to make things stronger or weaker for you or what have you. And you also marry with focus, the suggestion was, put your social media, put your phone away, put it in a different room, which is something, for example, I know Andrew Huberman does this, right? So he like locks up his phone and literally
Right.
puts it somewhere that's impossible for him to get to during the day. And that's sort of a behavioral manifestation because he knows that the temptation for him, if he sees his phone buzzing or even just by virtue of it being in the same workspace as him, is the likelihood of him picking it up is going to be much higher, right? So I think you do a really good job of that. Let's start off. We were talking in the pre-chat, and I thought we might start here, and then I want to talk about cardiovascular disease. But maybe let's start off by talking about biological age, so our actual age versus how fast we're aging. This is often talked about chronological age versus biological age. What can our genome tell us about how quickly or slowly we age, and what are some of the action items that we might consider around optimizing aging well?
So if you look at the innate hardware, right? Like here's your cells, here's your DNA. There's a cap on the end of the DNA called a telomere, right? And you've used this in practice. I'm sure you measure them. There's some algorithms that will tell you, here's your biological age based on how much telomere density is remaining, which is essentially a question of wear and tear. So if you look at the innate structure, it looks like our DNA is designed to last 120 years. So if you're born with optimum telomere capacity and high quality DNA that hasn't been oxidized or damaged yet, your cells are still tightly packed and not unwound and they haven't aged, that should last to 120. The habits we have, the choices we make, take years away, right? It's like you eat the wrong thing, stress yourself, don't sleep properly, you lost a week, you lost a month, you lost it, and you eventually chip away at that gift you were given of 120 years of life. And there are people that have lived to 120. In fact, I just read last week about a lady from France who inherited a multi-billion-dollar fortune, who just didn't do anything but enjoy her life. And she lived to 122. She had zero stress, zero problems. All she did was socialize and have fun, and she lived to 122. Right? There was no reason for her to age. So now, if you look at that, and okay, that's the potential. That's what we think potential is. What causes us to age? We already know what all those things are. It's it's the stress, the oxidation, the free radical activity. It's hormones. It's lack of sleep. When we use our genome for that context, it's let me prioritize the red flag in my genome that points to a failure that's going to equal taking those years away. It could be that, we talked about this last time, atoxic estrogen, for example. You may be a woman that's walking around just making far too much estrogen.
I make the toxic estrogen. Hi, it's me. The problem is me.
Yeah, exactly.
That's me.
That's you. And now you've done amazing stuff to manage and mitigate that. But if you didn't, what if you didn't?
What if I didn't know? If I didn't know, I wouldn't.
Know,
yeah.
Right?
Yeah.
So that's the thing where why is it that women, when you get to a certain age, all the chronic diseases hit so much harder? Because there's that cofactor of the estrogen toxicity. That's going to take a couple decades away, right? It could be somebody walking around with the worst version of the GSTP1 gene. They just don't block inhalation-based toxins from entering the bloodstream, and they're living in a city, or they are working in a factory, or they have a garden full of pesticides, and the years of exposure are going to take a couple decades away. So ultimately, we should live with full vitality, energy, libido, like quality of life, all that stuff until 120. Our habits take things away. Our DNA will tell us what system to prioritize and focus on, because that's your suboptimal system. And then you know exactly what habits to adopt. Just like Andrew Huberman says, I need to lock my phone away because of the way the neurology of my brain works. I cannot help myself. Some people don't have that problem. They think, well, what a psychopath. Why can't he just say no? Because he's not wired like you, right? So just understanding your wiring, prioritizing, and having the habits aligned with that.
Yeah, I love that. And does the in your book you talk about, when we're in the longevity chapter, you talk about lobsters and jellyfish, which are, the jellyfish just basically sink to the bottom of the ocean. They're rebirth again as baby jellyfish, and then they start sort of anew. And lobsters, of course, I think it's the telomerase. It's the enzyme that continually repairs the caps, like the telomeres. Is there any suggestion that, let's say, in humans, that we might have any genes that are, for example, the activity of telomerase or anything like that that can contribute to even some of these longevity pathways like FOXO pathways that
Yes.
we often see in centenarians and supercentenarians. Is there any evidence of genetic contribution, let's say, to how long someone's going to live?
So FOXO3 for sure, you nailed that one, right? Like that's, you look at that, this whole process of, the dying off of senescent cells, replacing with healthy cells, millions of cells per day. How efficiently do you do that? Some of us do that at a superhuman level with the FOXO3 gene. And so we're now, something that I haven't publicly talked about, but you're drawing this out of me. We're now working on genetic therapies to upregulate the FOXO3 gene. So people go for stem cells, they go for regenerative type medicines. So if I know that the FOXO3 gene signals to your body, stay ahead of cellular senescence and just live longer, stay younger longer, what if I can upregulate that gene by through its genetic expression? And we've been testing this and it works. So fairly soon you're going to see this come to market where we can now literally upregulate the gene through regenerative type medicine. And so there's like working on the actual function. Here's what the body does. Let me do that a little bit better. Then there's also slowing things down, right? So we also know here's what I want optimal, but here's the thing that usually leads to aging problems. For example, we know that plaque buildup in the brain, cholesterol, which is being used to mitigate inflammation, plaque buildup, and you said we're going to talk about cardiovascular health. How do I mitigate that, right? So it's how do I speed up things that are giving me life, and how do I slow down the things that are taking it away and aging me? Both of those things are now highly possible, and you're going to see in the next couple of years some really cool stuff coming to market.
Awesome. I love that. That's very exciting. And I think, yeah, there's a lot of researchers that are looking at how we can live longer. But I think at least for me, where I am right now is how can I, maybe if it's longevity, maybe it's lifespan, but I certainly am very concerned about my health span. Like I want the
Yeah.
years that I'm here to be enjoyable ones. I don't want to be ratcheted up on several medications. I want to have full mobility. I want to have my cognitive faculties there. So
Yeah.
it's very exciting for me as well. And yeah, as you mentioned, I wanted to talk about cardiovascular health. It's something that I've been paying more and more attention to. I've always, I was a fitness teacher, the step teacher. That's how I paid for part of my, my professional training. Is I was the
Yeah.
high-low kickboxing step teacher. So always have done a lot of cardiovascular work. Of course, I've also done a lot of weight training. So I've never really thought about my heart health per se, because I've always
Yeah.
just had this baseline level of fitness that has sort of followed me through my life. But now that I'm in my 40s, and I think going through the pandemic really, and now seeing a much higher incidence of cardiovascular events. So even whether it's, myocardial infarcts, it's spontaneous heart attacks, let's say, things like hypertension, cardiovascular disease. We start, in your book, I think that the quote that you opened up the book with is, if you're over the age of 10, the question isn't whether or not to eat healthy to prevent heart disease. It's whether or not you want to reverse the heart disease that you already have. And it just hit me, as a 45-year-old who's starting to think a lot about things like VO2 max and peak heart rate and heart rate recovery and all of these different things. So maybe we can start by talking a little bit about some of the genetic contributors to cardiovascular health.
Yeah.
And if you feel so inclined, we can maybe kind of go into inflammation and
Yeah.
hypertension, et cetera. So I'll throw it over
So
to you.
to understand the genetic insights, we have to sort of reframe what we think cardiovascular disease is. So most people think about the heart, and what we understand is that the heart keeps ticking until the last second, until you have that heart attack or whatever that episode is. It's the arteries around the heart that get calcified. They lose their elasticity. They get buildup of cholesterol and the plaque buildup. Right, that's where the disease happens. And so our research was focused on that. Let's deal with the actual root. And what we learned was genetically we can determine the quality of hardware. So here's your artery. Here's this tube, right? And the inner lining, the endothelium as it's called, we know what quality you have from your genetics. Is it stainless steel resilient or is it paper thin? So having said that, this is why we said it starts so early. Cardiovascular disease, 50% of North Americans are expected to have it. Why is this such a prolific number? Biggest killer in the world. I think 18 million people died last year of this
Men
one.
and women, ladies, it's not breast cancer. It's
Oh yeah,
cardiovascular
yeah.
disease, biggest killer in women as well.
Yep. And from breast cancer, the biggest killer actually is cardiovascular disease. It's not the breast cancer itself. That's what women actually die from, right? So not all, but majority. So why is this so prolific, especially in women? So that inflammation that sets in here, right, in the endothelium, leads to cholesterol being used as a tool by your body, a hormone, to reduce the inflammation. That's why your body deploys cholesterol and sends it there. In the beginning, that's okay. In the beginning, that doesn't show up in blood work, no problem. It's something your body's supposed to do. Now, given many other genetic factors, how efficiently do you transport lipids, the ApoE gene? Do you do this job well? If not, then maybe it's going to not be processed at the optimal and stay behind, right? How toxic is your blood? Meaning free radical activity from that cardiovascular activity you're talking about. Somebody that's running on a treadmill doing HIIT exercise every day that doesn't have the best antioxidation genetics, the ability to deal with the oxidant that's produced by using oxygen as fuel, right? We all do that. How efficiently do we clear? That's the free radical that may cause the inflammation. Your cardiovascular activity may cause your cardiovascular disease, right? Your glutathione pathways, and how do you deal with the airborne toxins or the consumed gut toxins, or entering through your skin, or whatever it is that may be inflammatory in nature entering your body? How well do you clear? So you start to look at all these pieces and say, well, here's this hardware. I'm causing it inflammation by one of these many things, and I'm now using cholesterol to support that. When the cholesterol meets the free radical activity, itself gets oxidized and hardens, and then it starts to build up, and this wall builds up, right? So that's the point where you start seeing numbers appear in blood work, and you start taking a pill to reduce, suppress the, like a Lipitor, for example, number one prescribed medication in North America, to suppress this buildup, when that's not the disease. The disease is endothelium inflammation. And this is why it was so important to talk in the book about it starting early, because it takes a long, long, long time to get there. The other thing that happens, why does it manifest in your 50s usually? That's when your mitochondria falls off a cliff. So,
and you've had 40 years of the disease incubating, right? It's
yes,
been incubating for 30, 40 years in the body. Yeah.
Yeah. And you've gotten used to those habits, and you think that they're okay, because at that age, the body was resilient enough to deal with those habits. Then your mitochondria falls off a cliff. The highest density of mitochondria in your body is the heart, the cardiovascular system. And all of a sudden, you don't have the cellular resilience to fight back, right? There's these front soldiers that were there ready to push it away, and they're just not there anymore. And by the time you're 70 years old, you've lost 70% of your mitochondria, unless you're actively doing something to maintain, And so this is perfect storm that occurs. The environmental toxins, the food, the stress, everything is worse than ever before. And some people have bad hardware. Some people don't cope with those stressors and toxins. Some people don't fight the inflammation well. The methylation support, like how do you actually, now that we know this is inflamed, how well do you fight it? Even more cholesterol being deployed. So that's the actual disease. So if I test a 5-year-old child, I can tell you what their propensity is and what exactly to do about it so they don't get sick. Here's the set of habits that if you were to go do these things, you're almost certain that you're going to have a cardiovascular condition. And here's a set of habits that if you do, it's pretty much certain that you won't. Right? And by the way, if you are sick, we can reverse, because we now know the root, and the body will heal. We've taken hundreds of people off of Lipitor, by the way. The one last thing I should say, you pointed out, how this affects women. 66% of women will die on their first cardiovascular event, and they didn't even know they were sick. There's no symptoms or no warning. So it's a much bigger problem for women. It's studied and researched in men. When we see it on TV and we hear about it in the news, it looks like a very male disease. The numbers are bigger in men, it's total numbers, but the outcome is much worse for women because of the estrogen toxicity and these other factors, right?
And part of it is that I would say that women experience, when they are having an active infarct, the symptoms, the presentation is different than men. So we often think about this left-sided pain shooting down the arm. I was taught that. That's like one of the classic signs of a heart attack. if you're male, right?
Yeah.
If you're male, and even then, but women often it's like indigestion or a
Yeah.
really bad headache. They'll say this is the worst headache I've ever had.
Yep.
That's how they'll present. So they're usually like take a Tylenol, go home and rest, right? So there's
Yep.
also there's the outcomes that you're talking about, but part of it is because our physicians, unfortunately, aren't. I think it's changing. I'd like to think and hope, and that it's changing. But it's the misdiagnosis and the emergency physicians actually missing that a female is actively having a heart attack because they don't actually know what the signs are. What to look for, because they do present differently for women. It's like indigestion and a headache. Like, what are you going to tell someone that?
A huge problem where women, so like you said, it is changing, right? So the good news is it's changing,
Yeah.
but there's two problems. One is that, so the root of it is women were excluded from clinical trials. They were in the beginning included, and then some pharmaceutical company said, wait a second, there's a menstrual cycle that's screwing up everything, so we're going to get rid of women.
Those pesky menstrual cycles.
Yeah.
Yeah.
So they eliminated women, and then people pushed back and said, how can you make a drug with half the population not included? So they
Right.
said, okay, we'll bring women back, but they brought postmenopausal women that don't have a cycle, right? So now now that's number one. Problem number two is that there is new research and data, but the numbers say that from the day that something exists, it takes 25 years for a clinician to adopt it. So when you go to a doctor today, you're getting 25-year-old information and technology. That's how risk adverse they're taught that to say no more than they say yes, right? So even if it's approved and it still doesn't enter practice, the person who's your quarterback. And so this is why it's more important than ever today, especially for women, to get out there and find the newest information, bring it to your clinician with the proof, with the evidence. And it's easy to do now. You couldn't do that before. We didn't have access. It's everywhere now. Dr. Google should be your friend. Don't worry about right? Find the information, find a functional medicine practitioner that has more, and then bring that to your clinician.
Yeah, it's no for women. I would say that it's not a luxury. Like it's in some cases it is a case of life and death, that you really do need to be able to be your own advocate. Hopefully,
Yep.
your doctor is going to be an advocate for you as well, but you do need to be an informed patient. Um, I wanted to maybe double click a little bit on inflammation. So you mentioned them briefly, and I thought we might tuck into each of them. In the book, you talk about three categories of inflammation as it relates to cardiovascular health. One is how well you remove toxins from your body, so glutathionization, how well the cells respond to inflammation, which is methylation, you mentioned that, and then the tolerance of blood vessels to toxins. So maybe we can just double click on glutathionization for a moment. You mentioned sort of in passing, like, hey, I'm like missing one of these genes.
Yeah.
I too am missing some
Yeah.
genes here as well. So this is not the SNPs that we're talking about. We're not talking about the polymorphisms within the gene. It's like, did you get one from mom and dad? I got
Yeah.
nothing from mom. I got nothing from dad on two of my three. I think I forget, is it mu, theta, and pi, if I'm
Right.
remembering correctly, GST pi, GST mu, and GST theta. Talk a little bit about each of those if you can, and then whether or not, if you're missing one, if you're missing completely, like the gene is like deleted from the book entirely. Yeah. If you have one copy, two copies, how does that influence your ability to remove toxins from your body?
Yeah. So when we were in our research phase, one of the big questions is, what genes do we even report on? Right, because by the way, there's more GSTT genes or GST genes, more glutathione genes than what we report on. But what is the intention? What's wrong and how do I fix it? Right, where can I take action that has the most impact? So if I give you a gene that's 80% of the problem and then two more that are 2% of the problem each, that's just a distraction, right? Let's deal with where we can really, really push the needle. And so out of the glutathione pathways, of the 7,000 people we sort of studied clinically and helped and supported, which is where we learned from, these three genes mattered the most. And they also most likely had the variants that led to problems. So GSTP1, like you said, which cannot have the phenomenon we're going to talk about called a copy number variation. It does have your typical SNP or a spelling mistake. And GSTP1 is supportive of, call it first line of defense of the lungs, which is so important today. In fact, I was talking to this guy named Dr. Tom O'Brien. He is part of the sort of board of the Institute for Functional Medicine, so he's always learning new stuff. And he said he believes that today's Alzheimer's and dementia is 60% inhalation based, meaning what we breathe. And it's not that what you breathe causes the inflammation or the disease. It's just that we are living so much longer than we used to, but we haven't learned how to be healthy in those extra years we have.
Mm-hmm.
Right? We used to die at 30 and 40 and abuse ourselves and just die kind of okay because we were still resilient. We still had stem cells. We still had mitochondria. Now we don't in those extra years. And so we cannot tolerate those airborne chemicals, pollution, pesticides, etc., that are causing serious neural inflammation, which then leads to the plaque buildup and dying of brain cells, right? So GSTP1 is really important there in terms of blocking all this nonsense that you're breathing. GSTM1 is protective of the gut. Now here you can have this phenomenon you're talking about, a copy number variation. There's 3 types of variants you want to look at. A SNP, which again is that spelling mistake. A gene is thousands of letters long, and sometimes in a certain location there could be a spelling error, and then that gene functions a little different, better or poorer. There's also something called an insertion or deletion, which is a paragraph is missing as opposed to a letter spelled wrong. Or there's an extra paragraph. That's why it's an insertion or a deletion. Then there's something called a copy number variation, which is what you're referring to, which I don't even have the gene. It's missing, right? There's a variation in the number of copies, or I have an extra one. Bryce from our team, who I think you know, right? He has an extra copy of the GSTT gene. So he can go running and drinking and doing all this crazy stuff and just wake up and go to work like nothing happened because he's a superhuman detoxer. Wow. He can drink a gallon of paint and pee it out, right? He shouldn't do that, but he's just really good.
But he can, yeah. And here I am, like avoiding rug stores, and, you know, like making sure that I have no fertilizer on my lawn and everything is organic in my house because I can't deal with it. I'm a very poor detoxifier. I'm a very poor methylator as well. Yeah.
So now you have a very clear view into what your body's doing with all of these threats that we know are coming in, along with our food, along with what you breathe, perhaps even what you touch that enters your bloodstream, your cosmetics, etc., all that stuff. So when you know that, you again know what to prioritize. Here's 2 things I need to do. I need to remove certain things from my life, like you just talked about, and I need to add supplementation to make up for the job that I don't do. I don't detoxify. You can't live like that if you want to reach that 120, right? So I need to add NAC or glycine or even glutathione or different things that help me get to that do the job that I just don't innately do. And then all of a sudden you get better and you get better and you get better.
NAC, just as a side little tangent, is kind of under attack as well, isn't it? They've removed NAC.
So things that work well in the supplement world are under attack. Yeah. And they're trying to say that it's a drug. The FDA is saying this should be prescribed. It is actually used in hospitals in the US and in Canada. And this is where they're saying that let's get it off the shelves because so many more people are now taking NAC, glycine, and other things that aren't sick. And if you're not sick, this $4 trillion healthcare industry that we have in North America doesn't do so well. So all of a sudden, lobbyists start lobbying and things change, you know? So look what's happening in Canada right now. It's ridiculous, but with this bill just passed where in 2 years, you might not be able to buy vitamin D, you know? They're saying that literally phase 1 drug trial level scrutiny for vitamin C, right? And why? Because it's not evidence-based. We just talked about Lipitor, which is the #1 prescribed drug. If you go to PubMed, there's 11,000 publications on Lipitor. If you go to PubMed, there's 99,000 on vitamin D. 10 times the #1 prescribed drug, but it's not evidence-based, right? So anyways, just know that this is another reason why I got to be your own health quarterback, because where the institutions from where our information is supposed to come from have different motivations. Let's just say that.
Yeah. Yeah. Let's, there's so much more that I want to say there. Because for just as an analytical thought experiment, what is the value if there's no, well, maybe I'll ask you, and you might not have the answer now, and this is something I'm probably going to research after our conversation today, but if NAC doesn't pose any health threat, let's say you take the supplement And maybe you overdose it. Maybe, you know, there's always someone who's going to do something silly with it. That's why we always have
Yep.
these silly labels like, warning, the coffee's hot. Don't pour it on your lap, you know, or whatever. So we always have these kind of labels. But what would be the impetus? Like, what would be the reasoning that someone could justify taking it off the market if it helps so many? And it's like, I try not to put on my tinfoil hat, but there it fucking is. It's like, it's hidden in plain sight. It's like, why would you take it off if it's helping so many people? Why would you do that?
So to your point, if it's not safe, okay, let's work on it, right?
Yeah,
Maybe it
yeah.
does need extra research, right? So then let's look at that. This group that's been tracking natural health products in Canada, I can speak to the Canadian stuff because this is where the problem's happening right now.
Yeah.
Their job is to look for that, exactly that problem.
But NAC in the States too. They've taken, like, they're trying to take NAC off the
They're
shelves
trying
in
to,
the
yeah.
States. Yeah, they're
Yeah.
doing it in the States as well.
So this regulatory body that oversees the safety of supplements in Canada since 1965 has been tracking safety and efficacy, right? Since 1965, they have recorded 0 deaths, 0, right? So that's the data that they have. This is coming from the Canadian government. Since 1965, if you even take the most benign, like Tylenol, right? 38 deaths a year in Canada, which you can buy over the counter at a Shoppers Drug Mart or a CVS or wherever you live, right? So if that has 38 deaths a year and you have 0 from all supplements combined since 1965, where does this argument come from?
Yeah. Yeah.
So motivations are not what we think.
Yeah. Oh, it makes me so angry. It makes me so angry. Okay, let's talk about methylation. This is in your book. You talked about this idea, like how well the cells respond to inflammation. So we were talking about the COMT gene. Can you speak a little bit about COMT and any other genes that sort of contribute to the cellular response within the mitochondria, let's say, to inflammation?
So the methylation, first of all, the big thing to correct is people talk about MTHFR, be all and all, and that's it, right? And even today, a lot of...
How dare you swear on this podcast? No, I'm just joking. I'm just kidding. The MTHFR, that's all, that's the famous gene that everyone, it sounds like a very bad word. Anyway, continue. Yeah, that's my pathetic attempt at a joke. Go on, Kashif.
So, that's not what it was. It's the name of a gene.
Yes.
And it's the name of a very important gene. And it's the name of a very well-studied gene. But the way science works is you take published data, and that's what you talk about. And you don't look at things functionally, you look at things siloed. So because there's published data around a gene, clinicians act on that gene. But that's not the way methylation works. Methylation is a baton pass from job to job to job to job, right? So there's this methylation baton pass that happens. So if you don't understand that MTHR is the central character, but there's things upstream and downstream, we don't take proper action. You're still not going to be precise. So as an example, if your MTHFR is up, everybody says, take some folate, right? SHMT1, so how many, like a pregnant woman, right away, take some folic acid. That's the first thing you're told, right? So if your MTHFR is off, but SHMT1, which is kind of a precursor to it, is off, then folic acid or folate won't work for you. You need folinic acid, very specific, folinic. And some of these people that take the folate over methylate, and they start to get headaches and weird feelings, and they're like, and then that folate that they took never gets blamed because no, MTHFR is off. You keep taking this, but let's now deal with your headache. And that's, the same problem that happens with other medication, right? So you can be a lot more precise if you first understand human biology. Here's how the body works. Here's the cascade in the system. Let's not separate the genes and treat them as independent siloed issues. They're not. They're part of a cascade that we already understand. Let's use the genes as per that map and then intervene where you actually need to intervene on the actual weak link of the chain, not just the end component or lock or whatever you're looking at, right? And that's where COMT also jumps in, because COMT isn't considered to be a methylation gene by many people because it's not part of the actual methylation cascade, but it is a secondary sort of step. And if you don't look at it, again, you can't be certain about what to do. So methylation is like, let's break down the toxins, make them water soluble, fight inflammation, all this stuff. And then COMT is like, let me open the door for all this stuff to get out. So if you speed up someone's methylation, attempting to help them, but they still have a slow comp, you're just clogging things up,
Backlogging the system. Yeah.
right? So you need to understand biology first, cascade first, deal with everything precisely in the place where it needs to be dealt with, and then you get these amazing, very quick outcomes. Like you really get people to help fast. And then the last thing just to say about this is single genes don't have single jobs or purposes. And so you also have to think a little bit more functionally, because if you speed up or slow down comp, it also clears your neurochemicals. It also clears your hormones.
I was going to
right?
say it's estrogen, very important with estrogen
Yes.
metabolism. Yeah.
Right. So now, depending where you're at there, you may start to have a problem. Like you may speed up, for example, neurochemical clearance, and all of a sudden have more addictive or reward-seeking tendencies or ADHD style behavior, and you wonder where that come from. So understanding again the full functional map, being very precise about where to intervene, and then you can do things right. It sounds complicated, highly complex, but it's really, really simple if you just look at the map, right? Just look at the full map. It's when you look at each individual gene and each individual problem that it becomes complex.
You mentioned Lipitor, statin metabolism. This is also where I think a lot of people, in the context of cardiovascular health anyway, and trying to, statins are often prescribed for, let's say, someone with a history of familial hypercholesterolemia, or their cholesterol levels are very high, or they've had, previous heart attack, something like that, and they've survived it, and they're put on usually a statin. Often statin metabolism is not taken into account. Can you talk a little bit about SLCO 1B1, I believe is what it is.
That's the one. And now all of a sudden, why is it that you have these side effect claims of statins, right? But they don't happen in everybody. If you are a ultra slow metabolizer, then the regular dosage is way too much for you. It sticks around for far too long, and it causes things like myopathy, pain, right? And if you're an ultra fast metabolizer, it didn't work because you plow through it so fast, you're not even utilizing the molecule that's supposed to get to work and do its job, right? So pharmacogenomics is a whole other class of genetic interpretation, and it goes beyond statins. It really, where it's powerful is in mental health drugs, mood and behavior drugs.
Yes, I was just going to say that. I remember having Dr. Kelly Brogan on the show, and she was talking about, I forget the term now, gosh, but it was people who are on antidepressants. They sort of get into this state of this irritation and this psychosis. And she was talking about some of the unfortunate fall-on effects of that is when you have someone who's trying to come off of a medication like that. They often... this is when you start to see, she was suggesting, where we see these mass shootings, let's say in the States, often it's because they've either just started some type of medication, and the way that they're metabolizing it is causing large amounts of toxicity in the liver and this like state of psychosis, or they're trying to come off of it, or they've just recently come off of it. Maybe you can speak a little bit more to that.
For sure. Yeah. And this is what we're seeing where you can be very precise about how the body metabolizes all the chemicals that you're using to manage mood. And if you're not precise, it's mood and behavior medication is where things can get really rough, really fast.
Yeah.
Because of what it's doing to your neurology. So, but you can also very quickly do it right. And when it comes to like the liver and all these other side effects, even something as simple as Tylenol, by the way. And I know we talked about autism last time, but I'll bring it up again. If you don't, again, understand the biology of how these things work, which makes things so simple and easy to understand. Tylenol, acetaminophen, like this chemical you're using, requires your glutathione stores to process. So when you take a child and you give them an injection, and that injection has heavy metals that are now causing inflammation, which then lead to a fever, and the pediatric standard is most kids will need some Tylenol after their shots, right? And what is the Tylenol then doing? Utilizing all of the glutathione, which is exactly what they needed to clear and bind the heavy metal they just got from the shot.
It's usually a prophylactic. They usually give them Tylenol before the shot.
Yes.
Right.
Yeah.
So then you're just sequestering and utilizing all the glutathione prior to the adjuvants.
Yeah. And you wonder why 1 in 30 kids is autistic now? When in the US, I think their vaccine schedule is like almost 80 vaccines now. It's getting kind of crazy, a whole other conversation. But,
Yeah.
this is where understanding, and this is not a secret that we know. This is known biology. This is known metabolic pathways. This is known, like, these drugs don't come to market until they're studied. So it's known how they're metabolized. The functional thinking of, do you combine this with this? What is the outcome of this other than getting rid of your headache? Right? What are the things that parents need to know? What are the things that I need to know for myself? None of that is discussed. It's just symptom and cure, symptom and cure. So, but it's known. That's the sad thing. It is known. If I know, I'm not a clinician, I'm not a scientist, I'm not a PhD. I just learned it because the information is out there. So it exists, right?
Yeah,
So
even antipyretics, like Tylenol is an antipyretic, so it's fever reducing. And I even just the idea of allowing your child to run let the fever run its course. Essentially, obviously, there's pathological fevers, so we're not talking about that. We're not talking about when the fever is over 104 Fahrenheit or over 40, 41 degrees centigrade. But like a 39 centigrade fever is a high fever, but in my house, that's just treated with cold compresses on the forehead, sleeping, and soup. Like that's there's no antipyretics, there's no Tylenol, there's nothing like that. Because the fever is actually, at least the way that I always say, I grew up in chiropractic, this sort of alternative, we'll say, to the mainstream. And we were taught fevers are actually an appropriate response. It's like a fever is appropriate response to the stimulus. Like as the body's heating up, you're now disengaging, or you're allowing for the invading pathogen. You're slowing down the reproductive capacity of the invading pathogen, and you're deactivating if it's a bacterial infection, you're going to be deactivating the proteins that are on the surface of the bacteria so that it can't propagate, right? So it feels like, you ride out a fever for a day or two, but they get cold compresses, they get popsicles, I make them popsicles and whatever, and then it's done. But we never give them Tylenol, never.
Yeah.
They're
lucky to have you as a mom. That's for sure.
Oh, thank you. I'm gonna play that recording back for them. Look at what this guy said about me, guys. You're lucky to have me, because they certainly don't think that. All right, let's talk a little bit about hypertension, and then we can move on to. I want to talk about mood and behavior. We've sort of been dancing around it a little bit too, but I wanted to talk about the ACE, angiotensin converting enzyme, and the ability, let's say, for ACE to control. Or not control blood pressure, salt reabsorption. Speak a little bit about that, and then that as a contributing factor to either to primary hypertension.
Yeah, so it's very clear, and so cardiovascular disease is one of the easiest things to deal with if you have your genomics in hand. None of this stuff needs to happen. So the hypertension that's caused by the ACE gene. And it's not only that, by the way, also the NOS3 gene and nitric oxide. So there's the hypertension, but then there's also the dilation, right?
Yeah.
So you combine these two and you have it figured out. Again, you have a child and you've understood exactly how their vessels deal with dilation and flow. And then you know what to do about their diet, right? You know what to do about their stresses. The things that doctors say about hypertension are true, but how is that an 8 out of 10 for me, or is that a 2 out of 10? Well, what priority level is that? And how much of that do I actually need to implement? So for the person that's off on their ACE2 and off on their NOS3, their nitric oxide, then this is a major priority. This is your choice between disease or not. But ACE2, just like COM, doesn't do one job. It's also the gene that viral infections use to proliferate and deposit their RNA into your cell, make you sick, including a very fancy virus we just had the last few years, right?
Well, it was like the ACE2 receptor. That's everyone.
Yes.
Everyone was talking about ACE2. Yeah.
Yeah, exactly. And it varies between populations. I don't know if you saw recently on the news with Robert F. Kennedy, the presidential candidate, where he came out and said that and he didn't say it conspiracy theory wise, but it was made out to be that way. He said that.
I did hear this. I think I know what you're going to say. It was like ethnic. There was.
Like the COVID virus was genetically engineered to skip over certain populations, including Ashkenazi Jews, right? He didn't use those words, but that's what it was turned into in the media. What he was saying, he was citing a study about ACE2 and a couple other genes, where I think it's like there's 61 locations on this gene where you look for variants that make it much easier for you to get sick from COVID. right? So we're not talking about death in the hospital. We're talking about how bad is the flu. And so out of those 61 locations, I think it's African Americans have 24 of them. So it's pretty bad. Some European populations have 35, I think. And most Ashkenazi Jews have 0. So he was talking about variability. So single genes don't have single purposes, and they also don't apply the same to different people, right? This is why personalization even goes to ethnicities. So when you talk about hypertension, the good version of the ACE gene in Western European, where the research is done, is actually the bad version for Asians. So the data that I would get from a 23andMe as an Asian person, South Asian, is actually the flip opposite of what's true for me, because there's other things going on. There's phenomenons called epistasis, where one gene turns another gene off.
And that's driven by cultural or cultural origin.
Yes, cultural, yeah. So then you can get a lot more specific down to like literally the culture. So all this information, this data is now coming together. So the ancestry stuff and the functional stuff and the disease stuff, it's all being packed up. We have to learn it all. The tools are going to get more and more precise as we move along. So that's what we've seen there. So and this is where there's been highly variable outcome in terms of how sick people get. One last note about it. The question of whether people end up in the hospital or not. ACE2, NIP21, and NOS3 are also indicative of not how bad was my flu, but did I get cardiovascular inflammation, which is one of the reasons why people end up in the hospital from viral infections like the one we just had. So these are another 3 areas where you look at to see, do I actually need support to be ready for the next virus? Because we already know the WHO's already dropped the mic and said that the next drop is 2025, right?
Yeah.
So it's coming.
And I've heard, this is unconfirmed, but they're like, we're going to make sure that it's toxic for kids this time around.
Yes.
That's the other, I mean, that's super tinfoil hat Stephanie talking here. There's no reference for that. I don't have a paper for that, but it's just, one of the things that kind of saved the kids last time was like that that immaturity, right, of that ACE2, the inability to invade for most children. Like most children were very protected from the virus. They had very mild symptoms, if anything.
Yeah. But we're getting an upgrade.
Yeah, we're getting an upgrade. God.
Yeah. So this stuff, this is why the beauty of genomics is if you learn, my intention is not to, as a testing company, aside from the book, it's not to like, here's your report and here's what it means. It's more like, let me teach you how to interpret your genome. And that's why the book was so important.
Yeah.
Go beyond just a report, because then you can use it. Like we just use it. You asked about ACE. We talked about 3 or 4 different things from the same one gene, right? So if you understand how your biology works, you yourself can interpret and become your health advocate, your own health quarterback, right?
Yeah. And you can import supplements from Europe because it's going to be the only place that you're going to get NAC and all the other things from. Oh goodness! All right, let's talk a little bit about diet and nutrition. I think that naturally follows after talking about cardiovascular and cardiorespiratory fitness. One of the things that I thought, so I want to talk about insulin sensitivity, but one of the things that I didn't know and I learned from your book was that there aren't variations in genes that influence protein metabolism. I didn't know that. I don't know why. I mean, I've always known about FTO and satiety and the amylase for carbohydrates and the PPAR alphas and gammas and all the stuff for fat metabolism and the apogenes and everything. And I don't know why I never put 2 and 2 together. So I thought that was really interesting. So that's something that I learned.
Yeah, it's really cool.
Yeah. But what I thought was interesting was you were talking about your own. So through the book, for the listener, you go through your own. It's so awesome. So you talk about all of these different categories, and then you talk about your own results and some of the things that you've done. And you were saying, because of your sensitivity, let's say, to toxins, while there's no variations in protein metabolism, let's say, things like charred meats, are you stay away from just because of the, maybe the TMAO content in them, or just like the charring of the, the meat itself is toxic, and you don't have necessarily the machinery to sort of clear that effectively. Can you speak a little bit about that?
Again, this comes down to what we just talked about, interpretation, right? So once I understand how my body works and I start to think that way, I have a new lens that I see the world from. You constantly are interpreting for whatever's in front of you. And what's in front of me today, there's meat. Okay, great. I do not so well with saturated fats, by the way, so I wouldn't thrive as a carnivore or a keto diet follower. I can use carnivore and keto as more of a therapeutic tool, 4, 5, 6 weeks to get rid of inflammation and calm things down, but I can longitudinally stick to it, right? So that meat's in front of me. I'm worried about the fat because I don't metabolize it well. And then I also realized that because I'm interpreting from my gut having zero detox, I cannot take toxins in with my food. So what toxins come along with meat is that charring, that carcinogen. It's truly a carcinogen that comes along with your blackened food. It's what spices got rubbed on there. Are those, is it a bunch of chemicals or is it real food that's used
laden with arsenic? Like where are they
yeah,
from? Yeah.
Yeah. And then the salts that are now, we're worried about microplastics in the salts, right? So things like that I have to think about because it may not be the plant or vegetable or animal itself, but the way it was processed foods, whatever. Another example. So I like sparkling drinks and I don't really have a sweet tooth, but I like sweet drinks, but I don't drink them because of the sugar. So I found a drink that had water, natural flavor, and stevia. I thought, okay, nothing wrong here. Natural flavor means it came from a plant or an animal. Good stuff. 3-4 days into it, I started getting headaches and kind of a brain fog weight to my head. I was like, what did I do? I didn't do anything wrong. And I kept drinking it, not blaming that. And I was like, the only thing I changed is this. So I started looking at natural flavors and I see that it's true. Natural means it comes from a plant or an animal. But to get it into the state that it can be used in your food requires between 50 to 75 chemicals. And none of those chemicals are listed as ingredients because they're not ingredients. They're processing chemicals, but you're eating them. Right?
And they can still call it natural flavor after they've added processing chemicals.
Yeah, because the component that is an ingredient is a natural flavor. The processing that's required to getting into your food is not considered an ingredient because it has nothing to do with the food label. It's not like what was required to make the food, it's required to process, right? So all of a sudden you have these inklings of like, I feel bloated, I had a migraine, my skin's a little itchy. Dive in. There's something going on there beyond the label, and especially if you live in the US, bread from the US is illegal in China and most of Europe because they use something called potassium bromate, which is what you make yoga mats out of. It's literally like plastic.
If you're watching this on YouTube, there's my face is in disbelief. Like who okayed that? Like where?
FDA?
God, we need the head on a platter. Why is that okay for the population?
It's not that it's okay for the population. It's that out of the various 50 states that exist, 75% of them, or I should say 75% of the jurisdictions where there's decision-making done, the biggest employer is either food or pharma.
Right.
So now food needs to be more profitable and pharma needs sick people.
And for all of the evidence-based trolls that might hear this and have the sort of response, well, like when it's a monotonic dose response, like the dose makes the poison. Show me the randomized control study that talks about all of these toxins in aggregate and the body's ability. Because this is what I hear all the time, which I sometimes roll my eyes so hard. I like to say that I give myself like a mini lobotomy. It's like they're like, but the dose the dose makes the poison. The dose makes the poison. It's like, show me the studies where they've looked at these small doses all together in aggregate in what we're, how many products does a woman put on her face in the morning? She puts on, I don't know, cleanser and moisturizer and then a base for her makeup and then her makeup and then some eyeliner and then some mascara. Show me the study that looked at that.
Yeah.
There's none.
Nothing is thought of functionally. Anytime I talk anywhere, there's always that scientist or clinician that tells me why I'm wrong. And then I look at their data that they're using to show me why I'm wrong. And it's always that. It's siloed. It's a sliver of the story.
Yeah.
We studied X. We studied whatever, right? Yeah, you studied it not in the way that it's applied in living in this world and planet and how we actually do things.
Yes.
Right? The total load. And yes, it's true. We do have detox capacity. We do have anti-inflammatory capacity. The total load, the bucket is overwhelmed. Right? EMF, it's everywhere now. Electronic signals. This phone that I have here signals to a cell phone tower 900 times a minute, 15 times a second. And it's in most people's pockets all day long.
Yeah. For men, it's like near their reproductive organs, right?
Yeah.
And for women, I don't think women really put it in their pockets. It's usually in like a purse or something. But like I see women just holding it all the time,
Yeah.
always holding
All
it,
day.
right? Yeah.
All day. And then that load plus this load plus this load plus this load, the
Right.
total is too much. The reality is our DNA as it stands right now is 250,000 years old. So our genetic code, we have not changed. We have not evolved. It's funny that when you look at evolution, it's not that our DNA is evolving. It's like you said, mom and dad gave me a copy. And it was a genetic lottery of which version I got from mom and dad. Now, between those same copies, you're giving it to your kids. There's only 2 or 3 possibilities for each one of those genes. And it's just a constant change. So grandma and great-great-great-grandchild may be identical because it's just a constant playing of these cards, right? So our DNA hasn't changed in 250,000 years. What has changed is the environment, the food, the water, the not going outside, the not sleeping, the relationships being toxic, all of that stuff, right? And our DNA has not changed to catch up to that, to give us the capacity and ability to deal with our current reality. Since the 1970s, I think, there's 144,000 chemicals that have been introduced, mostly for food, by the way, which is unbelievable. EMF has been introduced. All the studies on these phones that tell us that they're safe. Here's another example of the siloed studies, right? The clinicians will argue, well, the FDA studies are, the phones are safe. There's no problem. They were done in the 1980s when the phone was a brick, not a supercomputer with 5G. Very different context. The studies have not been changed since then. Also, they were done on military men whose skulls are 4 times the thickness of a child.
Right.
Completely different context. And there's a study that just came out of India, I think, where they're saying there's like a 400% increase in brain cancer in the adolescents now, teenage years, because it takes that many years as a 0 to 13-year-old of overexposure to then eventually lead to that brain cancer, right? 400% increase. So there's data on both sides, but I believe the anecdotal stuff because it's practical, right?
Yeah. All right, let's talk. Let's come back to let's talk briefly about insulin sensitivity. I thought that this was another thing that I learned from you. I always learn so much from you, Kashif. It's always wonderful. But the efficiency by which your body responds to the signals of insulin is also in some, like there's a big epigenetic component to this, certainly with lean muscle mass and all of that. But we do have genes that also influence our sensitivity to insulin. Let's speak briefly about that because I thought that was fascinating.
Well, my middle son, who he's now 7, he was around 5 at the time, started school. We were told he had ADHD. And I said, he doesn't have ADHD. I've dealt with this kid. He doesn't. They're like, no, he won't do his homework, can't concentrate, won't focus. So I looked at his genetics, not to look for ADHD, but to look for just what's wrong. Again, look at the jobs, and then how does that get interpreted for this context of he's a drama queen and when it comes to his work. And what did I find? The AMY1 gene, which is what your body uses to metabolize starches into glucose and turn into fuel, he had the worst possible version. TCF7L2, insulin response, he had the worst possible version. He was doing his homework after dinner every day in a South Asian home where we ate rice. And the problems with the teachers were happening after lunch where he was having a sandwich, right? So what he was struggling from was a carb crash and coma. He did not have a mood and behavior issue. So knowing this, whether it's irrespective of age, knowing your metabolic pathway precise to you and why you feel the way you feel and how you should plate your food, you can very easily change the way you feel by plating the way your body was designed to metabolize. And if you don't deal with your insulin response, well, why is Alzheimer's called type 3 diabetes? Because we know that's one of the ways to get there, right? Cofactor to cardiovascular disease and so many other problems. So that managing and mitigating an insulin roller coaster is paramount to not having chronic disease. And we can be very precise about what to do for an individual.
And so how did you change your meal planning with your son? So did his lunch change? Did his the time that he did his homework change, or the type of food that
It
you served
was
at dinner change? What happened?
Yeah, it was a question of timing and also the food itself. So here's a challenge: it's not easy for people to change their habits. And if you have a household, how do you tell one person not to eat bread or not to have the dessert or whatever, right? So it's a lot easier to replace than to eliminate. So I started bringing candies and gummies and things to make him feel special that were flavored with stevia, not with natural flavors, by the way. You know, uh, things that were healthy. I had my mom help make things that were healthy, right? That were designed for him, whether it was almond flour or coconut flour, but things that were not glycemic index spiking. And we gave him the ability to get the satiety, the satisfaction, because his MC4R off, MC4R, sorry, gene is also off, which means he's constantly craving snacks and wanting more sensorial eating, like with the wow factor.
Mm-hmm.
And so that was a problem. He was also overdoing it. And so you just have to design habits that are aligned to the problem. And it was a little bit of changing the time, and it was a little bit of changing the food.
Well, this brings me to my next question, which is, so many women listen to the show or they follow me because they're looking for weight management
Right.
strategies and weight loss. Certainly, I think that becomes more important as we age because it gets more and more difficult. But part of, I would say, the experience of food is kind of what you just said. It's sensorial. There's like a pleasure component to it. And I've had this conversation with many individuals on the show, kind of online, offline, around the bio individuality, we'll say, in the response to pleasure,
Mm.
early emotional, we'll say, imprints of food.
Yep.
So and we can talk a little bit. We don't talk about all of them, but I think we've mentioned like COMT already. I think dopamine. Maybe we can talk a
Yep.
little bit about some of the dopamine receptors, activation of how long the dopamine kind of hangs around, how that can influence food choices, or why it's so hard sometimes to avoid the cheesecake or to avoid the
Yep.
beautiful South Asian, whatever rice, whatever,
Yep.
meal that, your wife or whoever has prepared. It makes it that much harder because we have these sort of different layers of, cultural, in a cultural setting, like, hey, this is like what we eat. We have our rice with our meat and whatever. But also the neurochemical cascade that can fall from that as well. If you're sort of wired in a certain way, you're gonna seek out that pleasure, that behavior that initiates that pleasure, maybe more so than someone who doesn't have that dopaminergic pathway or that activation
Yeah.
of the receptors. Can you talk a little bit about that?
Yeah, for sure. It's funny because when we talk to people about diet nutrition, we always start with their behavioral genetics, and they don't understand why. It's like, no, tell me what to eat. Well, first we have to tell you how to eat, how you perceive satiety, how you think about food, because you're not going to follow the plan. You're going to think you are. Something as simple. So let's start with the dopamine, which you brought up. There's people, and by the way, with dopamine, we find that most people are on extremes. They're either extreme, I don't bind dopamine at all, or I bind way too much. We don't find many people in the middle. So that means I either am addicted and I crave more and I structure my day around it and I need it and I need it, I need it. I can't get no satisfaction, right? Or I bind way too much. So I don't need it. I'm not looking for it. But when I find that thing, that wow factor, I binge, right? So when I get the ice cream bucket that tastes good, I will eat the whole bucket, right? The addict doesn't necessarily need the whole thing, but they need it like it's part of their routine. If they don't get it, they get very frustrated. So two very different ways to look at sort of the abuse of calories, right? And why you overeat and why you can't stop. And then those can be mitigated in different ways. You can upregulate your dopamine with cold therapy. L-theanine is a very basic supplement that allows you to feel more dopamine, right? On the binging side, you can speed up your comp so that you clear it a little quicker. You don't get stuck in that binge. So it's a completely different problem to solve, right? Then there's your serotonin response, which my son is also the worst possible serotonin recipient. His receptors are really short, and it's very hard for him to experience mood regulation. And so people like that are constantly irritated, stressed. Anxiety gets used a lot as a word because they're oversensitive to stimulus. They see and hear way too much, and every little thing that's going on, they hear the clock ticking, they hear the crumpling of the paper. It all gets to them, the things that people around them ignore, which leads to this irritability and kind of anxiousness. When you're in that state chronically, because there's so much stimulus today, remember this wiring is designed for cave people who didn't have our level of stimulus. Now you put that in today's context where there's way too much stimulus, chronic, ongoing, the body knows that this is not a healthy place to be. You're in a cortisol response constantly, which in itself is a disease maker, right? A constant cortisol response. So it says, let's make you happy. Let's crave some soul food, the good the cheesecake that you were talking about, right? So that's that person that has the emotional eating, that is using food as a coping mechanism, and they don't count those calories because that hunger is perceived as real. They actually think they need it when it's actually just a response to a stressor.
It's not physiological hunger. This is like a psychological hunger, really.
Psychological hunger, yeah. It's like my gut's not empty, but I know I'm hungry, right? And you actually think you need it. So, and this is one place where we've seen over and over and over again, people get stuck, and it's related to their work or it's related to their relationships. They have some chronic stress trigger, and because of their serotonin dysregulated thinking, it's pushing their body a little too hard, and they're constantly using food to cope. Or they may use something more nefarious than that. It could be a drink or a smoke or something else, right? But it's usually food. So we deal with all of these things first, and the FTO gene you also talked about, which is sort of, we talked about satiety of the palate. Then there's also the gut, the signal between the gut and the brain. Am I actually full? And for some people, that just takes longer. And so you need to plate your food and know it's a glass of water or milk or something after to actually not overeat. You will go to the seconds or thirds or scrape it off the bottom of the pot, So let's plate your food and plan your meals as per the way you actually perceive, which is not baseline what you think. It's very different. So we deal with all the behavior stuff first. Then we actually get into the macros and the micros. Then we actually start saying, what do you eat? Now that we know how you eat, now we look at the what part. Another big one, I would say, ADRA2B and some people's propensity towards binding emotional stimulus, especially when it comes to negative, like holding on to trauma, and that associative trauma that leads to under or overeating. So there's scenarios where the pain is too much and you can't eat, and there's scenarios where the pain pushes you towards eating. And so that feeling of trauma, like this household makes me feel this way, this person makes me feel this way. When this person frowns, I get anxious. Like, what did I do this time? Because you're binding the feeling of the last interaction you had with them. And if it's chronic in nature, again, ongoing, that's how you perceive them. Where somebody else, this has nothing to do with last time. Tell me what's up. I'm not going to assume it's about me, because their ADRA2B pathway is optimal. They don't bind the feeling, they bind the information, the logic. So that's another big one where people get stuck. Their trauma response makes them behave differently in different contexts.
I think that is such powerful information to know. Gosh, because I think when you're, and when we're talking about dopamine in general and like addiction patterns, you talk about this in the book, this difference between like reward-based addiction and like binging type of addiction. Yeah. And you so beautifully synthesize, some of the other genes that can come into play with that as well. I've learned so much just from this conversation and in reading your book. Maybe we can end here, but I would love for you to tell people where, if they want to find the book, it's anywhere that, good bookstore, mom and pop shops, Amazon, the Barnes and Noble, all the places that they can find it, correct?
It's everywhere. I was in Washington, D.C. last week for an interview, and somebody told me to meet them at a mall. And I met them there, and then I saw the book at Barnes and Noble. I was like, that looks familiar. What is that? And I forgot that there's a book in a bookstore. Like, it's such a surreal experience, Yeah. So anyway, it's everywhere. Online, audiobook, it's all there.
And for those of you that want to get your DNA, so if you haven't taken your DNA test, so I've done this, I've done many genetic test, the DNA company is the only one that I recommend for practitioners that I work with, for individuals who are working with me. The DNA company is the company that you want to get it done from, because you're going to have all of this information that we've been talking about today is going to be laid out for you in such a succinct way. And I think that maybe you can speak a little bit about some of the services there. But I know that we have listeners of the podcast, if they want to get a DNA test done, like I've done one for myself, for my children, I've done it. I've done it for my husband, Giovanni, who you know. So our whole family has done it, because it's such powerful information. And as we've been talking about at the top of the hour, it's that intersection between genomics and epigenomics, and how we can modify our lifestyle based on the blueprint that we have. It's not just, yes, epigenetics are important, but you have to know how to, like what supplement you were saying to take, right? Like I'm the type of person, we talked about this last time, but if you give me too much methyl, like if you give me methylated whatever B vitamin you give me, methylated B12, B6, whatever, I'm going to get headaches, because of the way that, back to that methylation sort of pathway, my MTHFR and, other kinks in that whole system don't work as well. It's a relatively slow system for me. So you backlog it with all these methyl groups, and mama's going to walk away with a headache. So I know that methylated B vitamins are not the way for me. But there was a point in time where my naturopath, it was like the darling of the naturopathic community, right? Everything had to be methylated. Everything was methylated, right?
Yes.
So I think that it is such a powerful thing to do. So tell people a little bit about, if they want to get their own DNA test done for themselves, for their children. It's like a one and done, right? This is the thing I love about genetics, is like your genetics are not going to change, right? So it's like you take it once, you have it for life. So tell people about it and some of the services that the DNA company offers.
So I would say, firstly, don't go buy from the website retail. We want to, honor everyone in your community for joining us and spending time with us. So we have a code for you to use to save some money. TheDNAcompany.com/Dr. Stephanie, DR, it's DR Stephanie, right? Use that and you'll get a discount at checkout. When you get the test results, so there's a portal that tells you all about the stuff we've been talking about, but people often have questions, and it's the first time looking at this stuff for a lot of people, so it's hard to navigate. So we've set up these report review sessions that are live, where either myself or one of our clinicians will get on this group Zoom call. We'll sometimes have hundreds of people show up, and we'll go through each of the sections. We have a day just about the brain, a day just about disease, so we want you to get the experience that I kind of wished existed when I first started this journey, when I was sick and I started using genetic testing, right? So it's like, here's the report, simple, easy to use, but we're going to dive deeper. We're going to dive deeper and spend literally, it's a total of like 8 or 9 hours that we spend on these reviews with people. And you're welcome to join any one of them. If somebody has a specific problem they're trying to solve, you have to keep in mind that there's certain things that we know that we're not allowed to say because of Health Canada and FDA. So there's way more that we know than what's in the reports. So we have functional genomic practitioners, we have medical doctors, naturopaths, we have a whole team of people that you can work with. If it's like, my mom had breast cancer, I don't want it. These last 20 pounds, I don't get it. I'm stuck, right? These migraines just won't. So if there's a problem that really is acute, you need to resolve, we have a team, programs you can get into where the intention is, let's dive deep into your genome and we will figure it out. We will figure out exactly what's going on, give you the action plan and help you implement it. So that's what it is. So the DNAcompany.com/Dr. Stephanie, you'll get your discount there. And if you need more than that, we have a team to help you.
Awesome. So we'll make sure that all that's in the show notes as well. There'll be clickable links for our listeners. Kashif, always a pleasure. It's always a pleasure when I get to spend some time with you. I learn something, and then we can jam on some of our shared philosophies on what we're seeing in the world. So I always appreciate it. Yeah, thank you so much.
Pleasure.